Assalamualaikum Shabir.
Assalamualaikum.
Walaikum Salam. Hope you are doing well and everything is fine about you.
Mm, I'm fine.
Okay, so let's begin our today's lecture. Today is our lecture number 16. Have you revised your previous lectures? Is there any question regarding those lectures?
Not really, no.
Okay, so let's start today's lecture. So let me share my screen with you. Oh, my screen is sharing with you, right?
Yeah.
So here's your lecture number 16. And in today's lecture, basically, we will discuss some important thing which is known as the method of heat transfer. There are many methods of heat transfer. Some of important we will discuss in our today's lecture. Have you ever listened about some methods of heat transfer? Do you know
Um,
someone?
like combustion.
Like conduction, yes, you're right. So, yes, we will discuss some methods of heat transfer in today's lecture. Basically, our learning objectives are we will understand the three main methods of heat transfer. There are fundamentally three methods which are used. The name of them are conduction, the second one is the convection, and the last one is the radiation. These are basically fundamental three modes of heat transfer. Then we will identify some examples as well as applications of these methods. And then we will compare heat transfer process in solid, liquid, and gases. In solids, the mode of heat transfer is different as compared to liquid. And in liquids, the mode of transfer of heat transfer is also different from gases. So heat transfer in all these states in different scenarios. So we will discuss briefly. Then at last, we will solve some basic numerical problems involving the thermal energy. So before starting introduction to heat transfer, can you define me about heat? What is heat? How can you simple define heat?
Um, Burning fuel to cause energy.
Oh yes, you can simply define heat is that it's basically a form of energy. Okay, heat is a form of energy, and that only transfer due to the temperature difference. If there is no temperature difference, the flow of heat is no. But if there is some temperature difference, so definitely should be the flow of heat. So basically, heat is a form of energy you can see here that transfers from due to the temperature difference. And temperature difference created by if a body is at high temperature means hot, and if a body is at low temperature means body is cold. Can you tell me, body always transfer heat from hot body to cold body or cold body to hot body?
Um, Hot body to cold body.
Yes, heat always flow from high temperature to low temperature. As you know that the temperature for the hot body is high, that's why the heat also transforms from hot body and transmits into the cold body, right? So it's basically a form of energy and it always flow from a body at high temperature to a lower temperature until the thermal equilibrium is reached. Heat stops when the temperature for both bodies same. Okay. So at that point, we can say that our body reached at the thermal equilibrium condition when the temperature of both bodies, you can say, remains constant. Then we will discuss the amount of heat transfer. Basically, depends upon some factors. The one of them, which we already discussed, is the temperature difference. If there is a high temperature, means the body is more heat up. If there is low temperature, the body is less heat up. Also, it depends upon the nature of the medium. Okay, in hot summer days, there is more heat as compared to in winters, right? Because there is
Mm.
nature of medium different in hot days as well as cold days. Also, it depends upon the duration of transfer. Some bodies contain more time to transfer, and some bodies contains less time to transfer the heat. Here are the three primary methods which we will discuss briefly in today's topic. The first one is the conduction, the second one is the convection, and the last one is the radiation. So let's discuss the first one, which is the conduction. So here is the conduction. Conduction is basically the flow of heat by the physical contact of the bodies. Here you can see transfer of heat through solids without any actual movement of the particles as whole. It occurs due to the vibration of atoms and free electrons movement. So if you have a physical contact between two bodies, so the heat transfer method is known as the conduction. Okay, and this conduction arises due to the vibration of atoms. You know, every particles in the universe consist of atoms or molecules or free electrons as well. When those atoms, molecules, or electrons vibrate, their kinetic energy increases. And when the kinetic energy increases, we know that the body reaches to the high temperature. So by this scenario, you can increase the temperature of a body. So this concept is known as the conduction. And conduction only happens when there are physical contact between two bodies. If there is no physical contact, so there should be then is no conduction. So the physical contact between two bodies is compulsory in the case of conduction. And conduction happens due to the movement of atoms, electrons, as well as molecules in your body. Understood?
Yeah.
Okay. So heat transfer through solids without movement of the substance. And you know that solid also consists of atoms or molecules inside. And how can you convert solid into liquid? Can you tell me how can you convert a solid into a liquid? By giving temperature or by taking temperature?
Giving.
Yes, by giving temperature. So if you give a body which is solid a high temperature, so you can easily convert a body of solid into a liquid. Similarly, if you want to convert liquid into solid, can you tell me what you have to do? Either you have to give high temperature or you have to take temperature from your liquid body.
Take.
Yes, you want to remove the heat from a liquid body if you want to convert a liquid into solid, right?
Mm-hmm.
Hmm. And here you can see metals are the good conductors, like wood, plastic, and poor conductors are insulators. Okay, metals are good conductors, whereas wood and plastic, you know, these are not the good conductors. These are known as the poor conductors because you know that wood and plastic are called as the insulators. Do you know
Mm.
the difference between conductors and insulators?
No, really.
Okay, so what are conductors? Conductors are the materials which have free electrons. Okay, and
Mm-hmm.
insulators are the materials which do not have free electrons. A body which conducts depends upon the free electrons they have. If a body have free electrons, the body is conductive, means they conduct electricity as well as they also conduct heat. And if a body do not have free electrons, the body will not conduct, means they will not conduct electricity, they will also not conduct the heat. Everything in the universe consists of electrons, but some materials have fixed outermost shell, fixed electrons in their outermost shell. Those type of materials are known as insulators. They have no extra electrons. But in the case of conductors, they have electrons, but they also have extra electrons. And those extra electrons are called as the free electrons. And if a body have free electrons, that body is so called as a conductor. Okay.
Conductor.
This is a difference between a conductor and an insulator. Because conductor have free electrons, that's why they conduct electricity as well as heat. While insulators do not have free electrons, that's why they will not conduct heat as well as electricity. Examples of conduction are heating a metal rod. When you heat a metal rod from one end, you also visualize some heat coming to your hand. Am I right?
Mm-hmm.
So this is due to the conduction. When you heat a metal from one end, the atoms or molecules inside a conductor gain the kinetic energy and start vibrating. And once they vibrate, the body get heat up. And those molecules, because the kinetic energy is increased, also travel towards your hands. And you can also feel some amount of heat inside your hand as well, right?
Mm-hmm.
So, any question regarding conduction?
No.
Okay. So, conduction happens by the movement of atoms inside a metal, or you can say, or by the kinetic energy of a body. So, next, move on towards convection. Basically, convection is a method of heat transfer in liquids and in gases. As you can see here, which I mentioned here, you can see conduction happens only in solids, right?
Mm. Yeah.
But your convection, this will happens in only liquids and gases. You can see here. Okay, this is
Mm.
the first difference between conduction and convection. And convection happens again due to the movement of particles which is inside your liquid and gases. We know everything in the universe consists of particles. Your liquids and gases also consist of some particles. And by the movement of these liquids and gases, molecules, their kinetic energy increase. And if the kinetic energy increase of these liquids and gases, atoms or molecules, so the heat is formed, and that heat is so called as the convection. So the transfer of heat in fluids, liquids, and gases due to the actual movement of particles is called convection, right?
Yeah.
The important thing is that you have to understood that things which are less dense comes at the top, and things which are high dense sinks to the bottom. Okay. High dense means body has more mass, and less dense means body has less mass. So can you tell me, if a body has less mass, either they float or they sink?
Uh, less fault.
Yes, if a body has less mass means less dense, they float. And if a body has more mass and high density means denser, then they float or sink.
Uh, sink.
Yes, sink. So convection works on the principle of the same concept. The less dense fluid rises. When you heat a fluid, the less dense fluid rises, and the high dense fluid means heavy mass fluid sinks. And this phenomenon is known as convectional current. Sometimes questions arises, what is convectional current? So you have to say about this. Like when you heat up a fluid, the less dense molecules rises and the high dense molecules inside the fluid sinks. This phenomenon is known as the convectional currents. And this phenomenon happens when you simply boil a water. Here you can see, here is a bowl inside a water, and when you put into on a fire, here you can see the molecules of water, the less dense molecules of water will rise up and at the top of the water, and the high dense molecules comes at the bottom of this container. So this cycle is known as the convectional current, right?
Mhm.
Okay. Here you can see heat transfer from fluids, liquids, and gases by the movement of particles, which I already explained you before. And warmer, less dense region rises, and cooler, dense molecules will sink below. And this is known as the convectional current. Examples are simply boiling water, air circulations in room. Okay.
Mhm.
Any question regarding convection?
No.
Okay. So can you tell me convection happens in solids, liquid, or gases?
Uh, liquids and gases.
Right. And conduction happens in
Solids and liquids.
conduction.
Conduction
Yes.
is solids.
Yes. Only solids. Right.
Yeah.
Okay. Now move on towards the last mode of transfer of heat, which is known as radiation. Okay. Can you tell me what is meant by radiation?
Um, like heat radiating with waves and stuff.
Yes, waves and stuff like that. But simply, you can say radiation is basically a light. Okay,
Hmm.
every light you can see around you is basically a radiation. So, transfer of heat in the form of electromagnetic waves. And you know that
Hmm.
light are which type of waves? Either they are electromagnetic waves or longitudinal waves.
Um, electromagnetic
Yes,
magnetic.
yes, lights are electromagnetic waves. And what are electromagnetic waves? Electromagnetic waves are the waves in which there is a combination of two fields, electric field as well as the magnetic field. When electric and magnetic field both combines and the direction of
Hmm.
both fields perpendicular to each other, this type of wave is known as electromagnetic waves. Okay, and
Hmm.
every light in the universe is an electromagnetic wave, and this electromagnetic wave is called as the radiation. Okay.
Yeah.
Some examples are infrared radiations. Also, you know that there is ultraviolet radiation, visible radiations, okay, X-ray
Hmm.
radiations, gamma radiations. These all are basically the types of radiations.
Hmm.
So, the transfer of heat in the form of electromagnetic wave, like infrared radiation, without any medium, this is known as radiation. And radiation happens in vacuum. Okay.
Hmm.
And what is vacuum? Do you know?
Like an airless
Yes, like an air.
space.
Yes, airless that there is no medium. Okay, there
Hmm.
is no particle. So radiation do not requires any medium to travel. Radiation can easily travel in vacuum as well. And in vacuum there is no particles. But if there is vacuum, means if there is no particles, conduction and convection will not happen. Okay. But the
Hmm.
only thing that happens is radiation because radiation is a light and light is an electromagnetic wave and electromagnetic waves do not require any medium to travel. And in vacuum, there is no medium, so definitely light can also travel in vacuum. That's why in space, there is no vacuum, but the sunlight from the sun comes from sun to earth easily. Okay. This is all due to the radiations coming from the sun. Example is this heat from sun reaching towards the earth. There is no medium between earth and sun. It's empty space. But the radiations from the sun is easily coming from sun to earth. This is all due to the concept of electromagnetic waves, which are so called as the radiations. All right.
Hmm.
So the transfer of heat through electromagnetic waves or radiations, you can say it's a radiation, and radiation can only occur in vacuum, no particles needed. And all objects emit and absorb thermal radiation. You know, every body in the universe have a molecules, and when the molecules excites, and also when the molecules de-excites, they emit some amount of radiation. And this radiation can be in the form of visible, infrared, gamma, X-ray, depending upon the nature of the medium. Like from sun, heat coming from the sun, heat is also a form of radiation. You can feeling warm from a fire without touching. You feel warm when you standing in front of a firework, so you feel warm without touching the fire. Is I am right?
Hmm.
This is all due to the radiation. Okay. So here you can see a comparison table between conduction, convection, and radiation. Conduction happen only in solids, and this happens due to the vibration of particles. And the example is metal rod heating. While the convection, which is only happens in liquid and gases, and this is also due to the movement of particles, but those particles which are in fluid. And the example is the boiling water. And radiation travels in vacuum also in solid liquid gases, but also in vacuum. And how it works? Radiation works due to the principle of electromagnetic waves. And you know what is electromagnetic waves? Electromagnetic waves are the combination of electric field as well as,
With the magnetic field.
yes, as well as magnetic field. And what is the angle of between electric and magnetic field in electromagnetic waves? Can you tell me either perpendicular or parallel?
Um, Perpendicular.
Yes, electric field and magnetic field are always perpendicular to each other. Okay.
Yeah.
Example is heat coming from sun. So any question regarding radiation? Any question?
No.
Okay. So here you can see an illustration like when you heat up a rod, this end will heat up first, and below you can see heat will also transform to the back side of the rod. This is all due to the conduction phenomena. And when you heat up water, the less dense molecules rise up and the high dense molecules sinks. This is called as convection, and radiation, the heat coming from the sun in the form of electromagnetic wave. Now let's move on towards worked example. The first one is for the case of conduction. A metal rod transfers 1200 joules of heat in 5 minutes. So this is what?
Energy.
Yes, energy. And which type of energy? Either heat energy or something else.
Conduction.
So is this heat energy or something else?
Heat
Yes,
energy.
heat, because here mention, okay, of heat in 5 minutes. So the duration is 5 minutes. How much energy is transferred per second? You have to find the energy transferred per second. So this is the energy for 5 minutes, and you have to find the energy transferred per second. How you can find? First of all, you have to. So can you tell me what is the SI unit of time? Either minutes or seconds?
Seconds.
Yes, seconds. So you have to convert 5 minutes into seconds. How you convert 5 minutes into seconds?
Um, well, times it by 60.
Yes, 5 times 60, it becomes 300 seconds. And you have to find the energy per second. So it means you have to take the ratio. So energy is given is 1200. So 1200 divided by 300, which is the time. So you will get your answer, which is energy per second. It means the energy per second transferred to the metal rod is 4 joules per second. Okay, because
Mm-hmm.
the energy is a unit of joules and divided by times, and times is made in seconds. So the final unit is joules per second. The second example is a heater warms at 1500 grams of water. So can you tell me what is this? 1500 grams of water.
That's the heat.
Grams. You
Oh, the
can identify.
mass.
Yes, mass. So it means this is the mass of what? Of water. And the temperature of water is also given from this to this. So can you tell me what is this temperature? Either initial or final?
Initial.
Yes, and this is,
Final.
yes, final. And what you have to do if you want to find the change in temperature? What is the formula for the change in temperature?
Final minus initial.
Yes, final minus initial. So here you can see 50 minus 20, you will get with 30 degrees Celsius. And here is mass. And can you tell me what is the SI unit of mass? Either grams or kilograms?
Kilograms.
Kilograms. But in question, it's given in grams. So how can you convert grams into kilograms?
Divide by 1,000.
Yes, by dividing by 1000. So 1500 divided by 1000, you will get your answer, which is 1.5 kilograms.
Mhm.
The specific heat capacity of water is 4,200 joule per kilograms degree Celsius. How much heat is transferred? So you have to find
The
heat.
energy released
Yes,
or heat.
energy, or you can say heat. And another thing is given, which is the heat capacity, specific heat capacity. And you know that specific heat capacity is denoted by small c, right? Okay.
Yeah.
The specific heat capacity is denoted by small c, and the specific heat capacity of water is 4,200 joules per kilograms degree Celsius. Sometimes the specific heat capacity of water is given in problem, but sometimes not. So better is that you have to remember this value. Heat capacity of water
Hmm.
is 4,200 joule per kg degree Celsius. So you have to find heat, and you know what is the formula for heat? Q is equals to mc del T. Okay. Here m is
Yeah.
the mass, c is the specific heat capacity, and delta T is the change in temperature. All the things is mentioned, just putting the value of mass, specific heat capacity, and the change in temperature, you will get your answer, which is 189,000 joules. Okay,
Yeah.
because you know that the SI unit of heat is joules. We can measure heat in joules. Any question?
No.
Okay. So the last problem is from radiation. The sun emits radiation that reaches Earth carrying 1000 joule per meter square per second. Okay, so how much energy is received on the surface area of 4 meters square? So this 4 meter square is what? Area.
Um, area, yeah.
You can also identify from unit, meter square, and you know meter square is the unit of area. So this is value for area. So area is 4 meter square in 10
Hmm.
seconds, and time is mentioned, which is 10 seconds. You have to find the energy received on a surface area which is coming from the sun to earth. And power per unit area is also given. Here you can see
Hmm.
joule per meter square. Joule is a unit you can have power, and meter square is area. So it becomes power per unit area. So the value of power per unit area is 1000. And they're asking you to find the total energy. So to find the total energy, what you have to do, you have to just multiply your power per unit area to the actual area, multiply it the time it takes. So you have to multiply all these three terms, you will get your answer. So here you can see power per unit area, which is 1000, 4, which is the surface area on the earth, and 10, which is the time taken of by the radiation coming from sun to earth. You will get your answer, which is 40,000 joules.
Mm.
Right?
Yeah.
Perfect. Any question?
No.
Okay. Okay, so quick quiz for you. Can you tell me which method of heat transfer works in vacuum?
Radiation.
Yes, radiation. Can you tell me why?
Um, because there's no particles in space.
Yes, because
Or
there is no particles in space, and radiation is the one and only mode of transfer that do not requires any medium to travel. That's why this travels in vacuum as well. Okay, can you tell me what is a good conductor of heat? Either a metal or a plastic.
metal,
Okay, so metal is a conductor, and plastic is a
uh,
mm,
insulator,
yes, insulator. Can you tell me a difference between conductor and insulator?
um, conductor has free electrons and the insulator doesn't.
Wonderful. Can you tell me which forms during convection in fluid?
Um,
Which, which type of current forms in convection in fluids?
Convection currents.
Yes, convection currents. And can you tell me what does it means? Convection current means the,
Um,
the less dense molecules
the
rise
less
up
dense
or sink,
molecules rise,
and the higher dense molecules,
sink.
yes, sink. This is known as the convectional current. Okay, so can you tell me which surface is better emitter of radiation, either a black color or a white color?
Black.
Black color emits more radiation or white color?
Black color emits more
Yes,
radiation.
yes. And white color reflects more radiation. Okay,
Mm,
it means black color will absorb more radiations and white color will reflect more radiations because
mm,
black color is a good emitter and white color is a good absorber. That's why
mm.
in summer days we have to wear light colors because we have to reflect the light coming from sun, and in winters we have to wear dark colors to absorb some amount of radiations coming from sun to get our body some warm heat up. Okay,
Yeah.
so can you tell me what is the SI unit of energy?
Joules.
Yes, joules. And it's represented by capital J or small j?
Capital.
Yes, capital J. So here is some assessment questions for you. You can do practice at your home. Okay.
Mm-hmm.
So that's
Yeah.
all for today's lecture. If there are any question, you can ask.
No.
Okay. So if no, so that's all for today. Take care. We'll
Yeah.
meet next
Lapis.
weekend. Take care and Allah Hafiz. Shall we?
Lapis.
Thank you.
Okay.